Okay, I'm going to demonstrate some of the capabilities of the Stream Analyze platform. Here we have a device that is mimicking a quality control use case that we have with the client. It is a regular Raspberry Pi, and underneath there is a camera, and on top there's a touch display. And let's say that we're a manufacturing company that are manufacturing parts which have this sort of propeller-like structure. And we want our quality control system to detect whether there is some defect on our manufactured part. We have a schematic here that shows the setup of this demo. We have the green here, which indicates a Raspberry Pi that has a camera mounted to it. And on the Raspberry Pi, we have a Python application, and the Python application only serves as an interface to the camera. And within the Python application, we have an embedded instance of our Stream Analyze platform. And to this platform, we have deployed a model, and the model contains a neural network that has been trained on images on this kind of device, or on this kind of parts. And the neural network has been trained to recognize when the part is okay. So the pipeline of the model is we first take an image, and then we do some pre-processing on the image. We cut out the region of interest and we pass that on into the neural network. And the neural network takes that input and outputs an image that shows what the part will look like if the part is okay. So in order to detect an anomaly, we will have to take the input image and the output image of the neural network and take a difference between them. So we take the difference, and that produces a difference image. And from that difference image, we do some statistical analysis to determine whether there is an anomaly or not. And the result of the analysis is outputted to the screen. So let's see here. Here we have the live feed from the camera. You can see I'm rotating the part right now. So we trigger the model, and we see that we get an almost entirely dark blue image, which indicates that there's no anomaly on the part, and we also get quite a low score. But let's say that we introduce some sort of defect. Maybe the plastic has run out of the mold in the manufacturing process, creating this sort of anomaly on the part. And we run the model again, and we can see that we clearly have an indication of an anomaly in the difference image, and we also have quite high score, which sort of indicate to the operator that they need to take a closer look at this batch. Now I'm going to demonstrate some of the interactive capabilities of this platform. Let's say that we have deployed a model to the device, and that the model is not working properly as expected. Maybe it worked well in a lab environment, but when we took it to production, we see some kind of problem. So let's illustrate this. I have already deployed the model, which is defect, and you can see from the result that the difference image is quite distorted. So something was wrong. And we figure out that the thing that was wrong was that we cropped out a faulty region of interest. So we need to change the region of interest that we crop out. To do this, we can update the pre-processing step in the model. And to do this, we just deploy the pre-processing function, and we change the parameters of the cropping to the correct values. So now we're deploying the pre-processing step of the model to the device without doing a firmware update, without even restarting the application. So if we look here, we can see that we still have the application going. Nothing has changed, it's still live. But now, when we run the model, we will see that the model has been fixed. So we run the model, and we see that the difference image is now okay. The model has been fixed, and we did this interactively without doing any firmware update or not even restarting the application. And the function was compiled using a just-in-time compiler, so the model still runs as machine code on the device. Okay, the model runs isolated on the device. No data is leaving the device, unless you explicitly want it to. The Stream Analyze platform supports many different communication protocols to stream output data out from the device to, for example, a monitoring center or some control software. In this example, as you can see on the schematic here, we have added an output stream through the MQTT messaging service. So what we have done is that the results from the analysis pipeline is passed on to a public MQTT broker in the cloud. And we can look at this public MQTT broker. So here on the left, we have a subscription on the public MQTT broker. And to the right, we have the live feed from our device. So if we run the model, you can see that there's one data point that arrives at the public MQTT broker here. And we can expand this to see that the score was 49, as marked here. And just for illustrative purposes, we can add some more values. Let's introduce an anomaly here and do a new prediction. And we can see that the value is passed on to the MQTT broker. And the same if we remove the anomaly, and we will get a lower score again at the MQTT broker. So this demonstrates how you can easily pass on the data from the edge device to some sort of monitoring service